to be used in a printf. You like a new line and how to get a double quote, that kind of thing. Just review those. Review the formatting for include files, because I'm going to give you a question about include files, and one answer is right and three of them are wrong. So go over how they're formatted. Go over conversion specifiers for prints and how they're used. I will give you a little bit of code, and then I'll ask you what would print from that, and you'll have some choices to pick the right one. This one ought to be easy for people with your level of instruction, but go over precedence for arithmetic. And if I give you like 4 things to add, subtract, multiply, or divide in a row, and they got no parentheses, what happens first? Review how to create valid variable names, which is probably back in the very beginning. Probably back in C1 on start, where we just started going through all the nitty-gritty details of C. All right, this one's real hard. I will give you an expression, and I will ask you to fix it so it looks like a comment in C. You don't need to rewrite it. You just need to add to it. A comment. How to do a comment in C. Okay? I'll give you a few lines of code and then ask you to write a printf that would generate something that looks like this on the screen. What? Not up there. It's not up there. Yeah, I'm going to put the test up there? Oh, come on. Yeah. What? You need to be able to write a printf that would, I'm going to tell you what I want the screen to show, and you have to write the printf to do that. All right, then we get to files. So you'll have to write a file pointer. You'll have to do an fscanf using your file pointer. And you have to do an fopen with your file pointer. Those were out of order. You have to write a structure, type diff structure, with a few elements in it. Then after you write it, you'll have to initialize a variable with that, and you'll have to give a value to it. Then we have some stuff on pointers. This will sort of be like the front side of Lab 4. There will be an array, and there will be 3 lines of code, and you have to tell me what happens after each one, and at the end, tell me what's left in the array. Okay. Then we switch to the Linux Unix section of the test. You should know some of the basic Linux commands. ls, cp, rm, how to find help. All right, about file permissions. We assign file permissions to 3 different groups. Find out what they're named, because you're going to have to pick out a name that's not the right one out of the list. Another Linux command is cmod, so check up what that one does. You need to know the name of root. How do we write root? There's a couple of questions on VI. How to get from insert mode to command mode, and how to write and save your changes. Someplace in here, and I don't remember what set of slides it's in, we covered the 4 parts of program development when you're on a Linux machine, starting with the editor, the compiler, so forth. So you need to know what those 4 are and what order they happen in. Remember where we did that? Starting with the editor. I remember doing it. Might be in here. Oh, you guys are writing, I'll go looking. Yeah, it's in for Unix. You should know what the name of the debugger is. You should know the system calls for system I/O and be able to pick out a call that's a system call but isn't an I/O call. You need to know how we get a file descriptor, who gives it to us. You need to know the numbers for the 3 basic channels for an open. 0 is standard in, 1 is standard out, 2 is standard error. Those should be engraved in your brains. That's one detail that you should know.
Are those called again? Not the actual units, but
Yeah.
Well, they're they're the standard channels are, yeah, I think that would be a good description for that. When you open a process up, every process gets them. So your standard in is usually the keyboard, and your standard out is usually the screen, and then you have error, which you would go to the screen most of the time too. But they're in a level deeper than that. All right, you need to review. We had some tables about system I/O and what tables were open, and one of these is not in the kernel's view of I/O, and you need to know what it is. So we've done system calls so far. Read, write, open, close. We've done fork, we've done exec, we've done wait PID and wait. We've done an LC. So you should basically have a definition down for each one of those. You know what they are. Read and write, open and close are sort of easy, but go back and review on LSEEK and fork and wait PID. All right, I'm going to ask you if you had a short file and you wanted to display it on the screen in Linux, what would you use? Right? Cat would do? Okay. You have to write a Linux command to show the listing of files in a directory, but send the listing to a file instead of a screen. Redirection, yeah. And you have to write a Linux command to compile a file and have an executable that is not a.out. In other words, change the name as you compile. That's what's on this test. That's it.